Hello guys. Okay, we're still on periodic trends, and our new trend is electronegativity, which is the actual pull or the force it takes, the ability of an atom in a bond to pull on the electrons. Okay, and this is where your bonding is going to come in, and we're going to do a lab like that probably next week. Okay, so your electronegativity actually measures the attractions of an atom to another atom's electrons, okay, between your bonds. Okay, so now for your atomic radius, your trend is to increase from the right to the left and from top to bottom, and that's what we did since last Friday. Okay, so your highest atomic radius will be down here and your lowest will be over here. Okay, so now let's move on. Okay, now for your ionization energy is what we did this week, and the increase is going to be opposite of atomic radius. You're going to increase from the bottom up and from left to right. So your highest will be near helium, and your lowest is going to be down here. Okay, electronegativity is going to have the same trend. Okay, here we go. So our new one and the last one of our trends is electronegativity. So you're going to increase from the bottom up, just like the ionization, and it's going to increase from left to right, just like ionization. So you will have your highest over here and your lowest over here. Okay? So if I give you a list of elements, let's say something like bromine, which should be over here somewhere, and something like calcium, which should be over here on this side, which one has the highest? It would be the bromine, because it's closer to the right and higher up on the periodic table. Okay, so to kind of give you a better understanding, let's do a couple of examples. Okay, so go ahead and get your periodic table out and decide which should have the higher electronegativity. Is it sodium or is it chlorine? Well, if you look at your periodic table, sodium is in group 1 and chlorine is in the halogen group. So it's further right, and even though it's on the same period. So chlorine will be the element that has the higher electronegativity. Okay, now look at lithium and cesium. They're both in group 1. However, lithium is higher than cesium. Therefore, for electronegativity, cesium will have the higher electronegativity than lithium. Sorry. Okay, so now for bromine and selenium, which one would have the higher electronegativity? You can pause and look at the periodic table. Bromine is further to the right. They're on the same period. And so bromine will have the higher electronegativity. Okay, aluminum and AS is actually further right, so this will be the correct atom that has the highest electronegativity between these two. Okay, now these are again in the same group. They're in the boron family. So gallium is actually lower than aluminum. Aluminum is higher on the periodic table. So this will be the element that has the higher electron negativity. Okay, now some students find this a little tricky because sodium is actually higher up, but selenium is in the oxygen family, so it's far further right. So selenium will be the element that has the higher electron negativity. Okay, let's make this our last one, unless we need further examples. We can go ahead and do this after the video, and you're going to ask me in Zoom class, okay? So now helium is very far up, but fluorine is furthest to the right. Now, if you remember from the picture up front, some of these are an exception on electron negativity because they don't bond. Okay, so your fluorine here is going to have the higher electron negativity. Okay, very good. Okay, now this is an example of an electron negativity chart. So if I have a simple chemical like hydrochloric acid, let's go ahead and draw that out. What does that bond mean? You have 2 electrons, one from each, chlorine and hydrogen. And later on, we're going to show you why they share electrons. Chlorine is going to have a negativity of 3.0. And hydrogen is going to have a negativity of 2.1. So when you subtract these, you're going to have a 1.0 difference. This is going to be a polar bond. This means that one has a greater pull than the other on that bond. And we're going to be doing a lab on this later on next week. If I take a carbon, and let's make this a methane compound, okay, my electron negativity for carbon is 2.5, and hydrogen is going to be still the 2.1. Whoops, I needed to redo that. Okay, so here I'm going to have 2.1, 2.1, 2.1, and 2.1. So because all of them have an equal electron negativity force around the carbon, it's going to be an equal pull. So because it's an equal pull on every single direction, this is going to be a non-polar bond. And we will discuss this a little more later. If we have questions on any of this, let's go ahead and ask now in Zoom. Okay, also the electron negativity, it increases from left to right, correct? And that's because the most positive charge makes it more electron negativity. So when you have a nucleus inside your atom that has a greater charge, which this side has, that is part of why it makes it higher electron negativity. Okay? All right, I hope you guys are doing good. If we have any questions, you're going to go ahead and ask me or ask your teacher during Zoom. Okay? Bye.